Alright, so turn to a clean set of pages after the notes we just finished taking for Chapter 10. This will be page 41 of your notebook. Here's a review and a reflect. I know it's a little silly after the fact, but I want to keep our notebooks complete. So for the review, use radicals or rational exponents to simplify. So the first one, 125 to the 4/3 power, and the second one, the cubed root of x to the 7th times the 5th root of x squared. Then the reflection question, the same one I do before each test. Again, it's a little silly after the fact, but I do want you to write it down. What 3 things do you plan to do, or you can change that to did you do, to prepare for the Chapter 10 exam. So think of 3 things you did to prepare for the exam. I'm going to go ahead and work out the 2 review questions. You can try them on your own by pausing the video, and then you can play it back to see how you did. So let's look at number 1 on the review questions. The first one is 125 to the 4/3 power. So that's asking for the cubed root of 125. Remember, the bottom number is the root. Once I get that answer, I'm going to raise that to the 4th power. So the cubed root of 125 is 5, and 5 raised to the 4th power is 625. So that would be your final answer. For number 2, we have the cubed root of x to the 7th times the 5th root of x squared. I'm going to use rational exponents to put these together. This is x to the 7/3 times x to the 2/5. So the product rule for exponents says that I can add those together. 7/3 plus 2/5. Now off to the side, or in your head depending on your skill level, you need to add 7/3 plus 2/5. And in order to add those together, we need common denominators. So we're going to multiply the first fraction by 5 and the second fraction by 3. That's going to give me 35/15 plus 6/15, which is 41/15. That is going to be your final answer on that one. 41/15. Oh, and in my math lab, I always forget, if they start with radicals, they probably want you to finish with radicals. So it's the 15th root of x to the 41st power. So most likely that's the proper notation. Again, if you start in radical form, finish in radical form. If you start in rational exponent form, you would finish with rational exponents as needed. Alright, so let's get into that last topic from Chapter 10. This is the last section in your notebook for this chapter. I'm going to work on plain paper so I have plenty of space. So in your notebook, you're going to be on page 42. This is section 10.6 in your notebook on solving radical equations. The first thing you want to do when you're solving an equation with a radical is to isolate the radical. Normally this is done for you, but just in case there's anything next to the radical, you want to isolate the radical. Then you're going to raise both sides to the root's power. If it's a square root, you're going to square both sides. If it's a cube root, you're going to cube both sides. Once you do that, you're going to solve for x. Sometimes that's a linear solve. Sometimes that's a quadratic solve. We haven't seen too much quadratic solves, but we'll go over that. And then we'll see that again a lot in the next chapter as well. Then the last step is to plug in all your answers. You might have one answer, you might have two answers. to verify that they work. Now with radicals, it's kind of weird. Sometimes they work and sometimes they don't. So this is not optional. It's always good to check your work, but for this one you actually really have to verify your work before you move on. So you plug in all your answers to verify. If it doesn't work, it's not a solution. Alright, so let's look at example 1. If I have the square root of 3x plus 4 equals 8. The square root of 3x plus 4 equals 8. Now the first step says to isolate the radical. So you want to look at where the square root is and make sure that there's nothing around it. There's nothing being added or subtracted to it. In this case, that part's already done for us. Now we're going to raise both sides to the root's power. This is a square root, so in order to undo a square root, I'm going to square both sides. The square and the square root cancel each other out, and I'm left with 3x plus 4 equals 64. The next step is to solve for x. It's either linear, where you don't have any squared terms, or quadratic. Quadratic is when you have an x squared term. And we'll get used to that more in the next chapter, but when you have an x squared term, there's a different way of solving it. So this does not have an x squared term, it's just a simple linear solve. So I'm going to move that 4 to the other side. That gives me 3x equals 60. Divide both sides by 3, and x equals 20. And that is my final answer. Now normally once we get x equals some number, we just stop and we just trust that it works, and most of the time it does. Unfortunately, when you have a radical involved, you have to verify all of your answers. And so I'm going to take x equals 20, I'm going to plug it into the original equation, and I'm just going to make sure that it was a solution. So I have the square root of 3, I'm going to replace x with 20, plus 4, and I need to see if that equals 8. 3 times 20 is 60, 60 plus 4 is 64, and the square root of 64 is 8. You just have to make sure that that is a valid answer. If it doesn't work, then it's not a solution. Alright, let's move on to example 2. If you'd like to pause the video and try this one yourself, I do encourage you to do that. Example 2, we have the square root of 7x minus 3 equals 6. So if you'd like to pause the video, solve for x, and then don't forget to verify once you're done. Alright, so the first step again is to isolate the radical. Notice that the radical expression is the only thing on that side of the equal sign, which means it is isolated. Then we're going to raise both sides to the root's power. It's a square root, so I'm going to square both sides. That leaves me with 7x minus 3 equals 36. Then I'm going to add 3 to both sides. 7x equals 39. Divide by 7, and x equals 39 over 7, which is kind of an ugly answer, but we're going to have to work with it. Now from here I need to verify this. You can have your calculator help you out, or you can just plug it in and work it out. We have the square root of 7 times 39 over 7 minus 3, and we're hoping that that equals 6. Now you can type that in the calculator, 7 times 39 over 7, but the 7 coefficient is going to divide out with the 7 that is being divided by, and really that is just the square root of 39 minus 3. So these two 7's divide off, but you can check that in your calculator as well. 39 minus 3 is 36. The square root of 36 is 6. So that answer has been verified and is a valid solution. Alright, let's look at another one. Example 3. I have the square root of 5x plus 1, and then outside of the square root I have plus 3 equals 0. And I always like to write the word verify off to the side because otherwise I will forget. So we're going to verify that when we're done. Alright, so this time you see the radical, then the radical stops and you have a plus 3 kind of hanging off to the side. So we're going to move that 3 to the other side. That gives us the square root of 5x plus 1, that's the radical, equals 0 minus 3 is negative 3. So that's what I mean when I say isolate the radical. You want to make sure that everything under the radical is all by itself. From there, we're going to square both sides to undo the radical. That leaves me with 5x plus 1, and negative 3 squared is positive 9. Then I'm going to solve for x. I'm going to move that 1. 5x equals 8, divide by 5, and then x equals 8 over 5. And sometimes you just have fractions to work with, and sometimes you have integers. So with that, I'm going to verify that answer. So I'm going to plug in 5 times 8 over 5, and then plus 1 plus 3 equals 0. So again, the 5 and the divided by 5 cancel each other out. So this is really just the square root of 8 plus 1 plus 3 equals 0. So that's the square root of 9 plus 3 equals 0. The square root of 9 is 3. 3 plus 3 does not equal 0. So in this situation, this is not a valid answer, which means we have no solution. So mathematically we did everything correct. However, because when we plugged it back in it didn't work, we have no solution. Alright, I'm going to give you another one that I encourage you to try on your own. This is example 4. We have the square root of 3x plus 1, then minus 4 equals 0. So go ahead and give this one a try. Don't forget to verify once you're done solving. And I encourage you to pause the video and try this on your own. Similar to the last example, the radical is here and it's not isolated. So I need to add 4 to both sides to isolate the radical. That gives me the square root of 3x plus 1 equals 4. Then I'm going to undo the radical by squaring both sides. That gives me 3x plus 1 equals 16. So far these have all been linear solves, so it should be pretty easy to solve for x. I'm going to move that 1. 3x equals 15. Divide by 3. And x equals 5. Now I'm going to use that x equals 5 and verify it. So I'm going to plug in 5 back to the original equation. 3 times 5 plus 1 minus 4, and I'm hoping that equals 0. 3 times 5 is 15, plus 1 is 16. The square root of 16 is 4, and 4 minus 4 is 0. So that is a valid solution. Alright, so far all of the equations have been linear. Now we're going to move into a few equations that are quadratic. And I'm using up a lot more paper than I usually do, but I want to make sure everything's nice and clear for these. So just use as many EX pages as you need. This is going to be example 5. We have the square root of negative 10x minus 1, and then outside the square root we have plus 3x equals 0. So instead of just a constant here, we have a variable term. Once again, we need to isolate that radical. So we're going to subtract 3x from both sides. Luckily, we're subtracting from 0, which makes that easy. So negative 10x minus 1 equals negative 3x. Then we're going to raise both sides to the root's power. So we're going to square both sides here. That's going to give me negative 10x minus 1. Nothing changes on the left. We just get rid of the radical. And negative 3x squared. Negative 3 squared is positive 9 and then x squared. If you need to see that a little better, it's negative 3x times negative 3x, which makes positive 9x squared. So now we have a squared term, and we haven't seen it much throughout the course, but as you get into college algebra, you're going to see this more and more often. Anytime you have a squared term, it's called quadratic. And when the equation is quadratic, instead of solving for x by moving things to one side or the other, you're going to move all terms to one side. This way we can factor. So I can't factor when I've got terms on either side because I don't know where my a, b, and c go. So it's very important to move all terms to one side and put your quadratic in what they call standard form. So in order to do this, I'm going to leave my 9x squared where it is. I'm going to add 10x and add 1. So add 10x and add 1. This is going to give me 0 equals 9x squared plus 10x plus 1. So we have a squared term, an x term, and a constant term in that order. So it's very important to have the quadratics set equal to 0. And we'll practice this again in chapter 11. It's very important to have them all lined up into standard form. Now, anytime we have a quadratic, we move everything to one side. The next step is to factor. So we have to remember our factoring steps. So we're going to work off to the side here. We've got A, B, and C. I don't see a GCF, so I'm going to set up my CAB chart here. 9 times 1 is 9. Middle term is 10. 9 and 1 would be my pair. I'll leave that 0 there. This is 9x squared plus 9x plus x plus 1. I'm going to do my grouping, just going through the factoring trinomial steps. Second grouping is a plus 1 and x plus 1. Still equal to 0, and then when I reorganize, that gives me 9x plus 1 times x plus 1. Now with quadratics, you're going to get two answers. It's not a good color. Let's see here. So your first answer is setting the first factor equal to 0, so 9x plus 1 equals 0. The second piece is setting the second factor equal to 0. So then I'm going to solve for x. These are now linear. Divide by 9. So x equals negative 1/9, and then subtract 1. X equals negative 1. So I have two potential answers here. X equals negative 1/9, or x equals negative 1. Now I think the video is about to cut off, so I'm going to pause there. The question's not done because we still need to verify our answers. But I'm going to start a new video to verify these answers because I don't want the video to cut me off. So we'll just pause there, and I'll start again with verifying those two answers.